All right, so we are, I have, there we go. Okay, so really we've got some four goals that we want to talk about today. So the first one is it's just really to make us feel like we're actually doing something with our lives and allowing us to get back in front of you, teach like we normally teach so that it's not just you're sitting there watching videos and all that stuff of us. Okay. Um, Ease some of your anxiety over next week's quiz or next week's test. Next week's test, or the test that you will have on Thursday and Friday of next week, will be a summative. Okay, so that's going to be a summative that goes along with everything. Oops, hold on. Where did that go? I didn't want that up there. There we go. It's going to be a summative that deals with vectors, vector calculations, navigation, and magnitudes, direction angles, all that fun stuff. Okay? And then later on, we can talk about any questions and answers you have and things that we should be improving on as we go forward with this. Because let's be honest, it sounds like this is going to be the normal pretty much for the rest of the year. So just so you know. Okay? This sign, San Francisco put up these signs. We found this on, I think it was on Facebook. It's pretty easy to point out that by Pythagorean theorem, if they're 6 foot in the diagonals, that they're really only 4 feet all apart, because it's 6 feet divided by the square root of 2 gets you 4.1 feet apart. So that was a little math, people in math in the real world that people need to know about. All right, so here we go. First question, or first problem. Okay. A farmer wishes to remove a stump from his field by pulling it out with his tractor. And I didn't start this, or I didn't make this problem. That was a Mrs. Hill. Mrs. Hill decided what this problem was. Okay? So farmer needs to remove a stump from a field by pulling it out with his tractor. Having removed many stumps before, he estimates that he will need 6 tons of force to remove the stump. 6 tons is 12,000 pounds, 2,000 pounds per ton. And, however, his tractor is only capable of pulling with a force of 7,000 pounds. So he asks his neighbor to help. His neighbor's tractor can pull with a force of 5,500 pounds. They attach the two tractors with a 40-degree angle between them, between the two forces. Assuming that the farmer's estimate of a needed 6-ton force is correct, will the farmer be successful in removing the stump? So here is the diagram of the situation. We got the stump right here. We got the first farmer pulling on the stump in this general direction with 7,000 pounds. We've got the neighbor pulling in this general direction with a 40-degree angle in between them right there. Okay? So I'm going to just redraw this on my makeshift whiteboard. Okay? Which, by the way, my makeshift whiteboard. Let's see, why doesn't that work? No. There you go. My makeshift whiteboard also is my patio door. Okay? Alright, so 7,000 pounds here, 40-degree angle there. Oops, not degrees. 5,500 pounds up there. Okay? Now, just so you are aware, when I'm doing this webcasting type thing, if you have questions, I can't see the text. So you're just going to have to unmute your mics and jump in with questions, just so you are aware. Okay? So there we go. All right. So first one, let's call this farmer, we'll call A. We'll call him vector A. All right? So if I have that farmer So this is going out here with a trig angle of 0 degrees. Okay? So he is just horizontally pulling. So I could go 7,000 cosine of 0 degrees, 7,000 sine of 0 degrees. But knowing what we know, that is just going to be 7,000 comma 0, because the sign at, sorry for the glare going on there, I'm trying to adjust my lights so we don't have as much of a glare. Ooh, that's a little warm. I got my shop lights in to try and cut the glare down. So, okay. So we got that. Cosine at 0 is 1. So 7,000 times 1 gets me 7,000. Sine at 0 is 0. 7,000 times 0 is 0. So that's my first vector. Second vector, we'll call it B. Is going to be now 5,500 cosine of 40 degrees (5,500 sine of 40 degrees). So if we type that in on the calculator, ooh, that's really bad. Yeah. I'm trying. That's a little better. Okay. So if I type this in on the calculator, then I get a vector here of 4213.24 and 3535.33 as my vector. Okay. So the pulling, or the actual, what the resulting is, or the resultant vector is going to be somewhere in the middle of that, and we're going to figure out what force that's being pulled with, and what the magnitude is. We don't need to find the angle, we just need to find the magnitude. So the pull, we'll call it, is going to be these two added together, blue plus green. So 7,000 plus 4,213.24 is 11,213.24. 0 plus 33 is 35. OCD hasn't died yet. 35, 33. Okay? And we need to find the magnitude of that. Okay? So the magnitude of that is going to be, I'm going to take the the magnitude of the pull is going to be, I'm going to take the x part, square it, add it to the y part, square it, and then take the big square root of that. Huh? When I do that, I get 11,757.4 pounds. Okay? Now remember that the farmer estimated that we had, or that he needed 6 tons of force, which would be 12,000 pounds of force, they're only pulling, the two tractors combined are only pulling at 11,700 pounds. So this is a no, it will not pull the stump out. Okay. Let's see. That's not going to work. What if I went like this? There we go. Any questions about that one? If so, unmute your mics, ask it. Why there? I just had to get a. Everybody good? Me a nod or a thumbs up since you're all on mute. All right. Not used to talking. Got to drink more tea. All right, next one. Paige Nelson, don't look so bored. Next one is an airplane is flying on a compass heading or bearing, or so that's dealing with non-trig angles. Okay? So it's flying on a compass heading of 170 degrees at 460 miles an hour. A wind is blowing from a bearing of 20 degrees at 25 miles an hour. And we are asking you to find the actual ground speed and direction of the plane. So give me a second to reset the board / door. Wifey's liking this because the window has never been this clean. All right, so plane. First off, let me get myself. There we go. Okay. So first off, we've got the plane. And then we got the wind. Okay. So a plane is flying on a compass heading or bearing of 170 degrees. That is down here because this angle there makes 170. Remember, with bearings, straight up is 0, east is 90, south is 180, west is 270. Which would leave then a 10-degree angle to get back to due south. And that's important because the trig angle for this scenario would start here and go all the way around this way. So the trig angle there would be 280 degrees. So the vector for the plane is going to be, it was flying at 460 miles per hour. So then that would be at 460 cosine of 280, 460 sine of 280, which, again, type those in on your calculator, provided you're in degrees. Make sure you're in degrees, not in radians. That would give you 79.878 and negative 453.012. Now the light's in the way. Too much illumination. I'm trying for you. Okay. Everybody good on that one? Okay. All right. Then now we've got the wind. Okay. The wind, it said, was blowing from a bearing of 20 degrees. So a bearing of 20 degrees would have a 20-degree angle up there, but that's where it's blowing from. So it's really blowing that way with a 20-degree angle there, okay? Which is important because the trig angle then becomes 270 minus 20, or 250 degrees. Okay? So this vector then would be, it was blowing at 25 miles an hour. So that would be 25 cosine of 250, 25 sine of 250. So then that would be negative 8.551, comma, negative 23.492. All good with those? Anybody not okay with those? Okay. The formula that that we've been using is true is equal to the vehicle, the aim, whatever you want to call it, plus the wind. Well, the aim or the vehicle is the plane, so that's going to be our A. Our wind is going to be our W. So to find what's actually going on, I'm going to take these two vectors and I'm going to add them together. So 79.878 plus negative 8.551 gets me 71.328. Negative 453 and change plus negative 23 and change gets me negative 476.504. So that's the vector now that we are going to be dealing with. We need to find the magnitude of it. That gives me my speed. We need to find its direction angle. That gives me, or we need to find the angle of it. I can utilize that to find then my bearing. Okay? So the magnitude of G is going to be square the X, square the Y, take the square root of it. Okay? So when you do that on your calculator, you would get 481.813. That's the magnitude of that vector. So then that's going to be the speed. So that would be miles per hour. find the reference angle, and I'm going to always go with the reference angle there because we're dealing with bearings. I just always put it as a reference angle because we're going to be ending up changing it around anyways. So that's going to be the inverse tangent of, I'm going to drop the negative signs, y over x and that's going to give me 81.487 degrees as my reference angle. Now, based upon that, what I like to do is I like to draw myself another crosshairs. This vector has a positive horizontal component and a negative vertical component that puts me down here in quadrant 4, which means then that my reference angle, theta prime, would be coming off the horizontal, so it would be there. So this is 81.487 degrees. Bearing has 0, 90, 180 there. So I'm going to add 90 degrees to that to get my actual theta. 90 plus 180, or excuse me, 90 plus 81 is 171. Oops, I can take the theta off of there and I can just say bearing. Love, love, love it. Actually, wish I was teaching this to you guys every day because this stuff is awesome. Makes you think. Any questions on that one? All good? Oops. Can't see the bottom row. Now I can see the bottom row. Now I could see the bottom row. Now I can see the bottom row. Okay, all good? One last one to do, and then we'll open it up for questions and answers and all that fun stuff. There we go. An Airbus. Actually, why don't we do this? Why don't I let you guys do this one? I'll give you a couple of minutes to do it, and then I'll check back in with you. So why don't you guys do this one and try it, and then I'll go over it. We'll do it like we'd actually do in class. All right, so again, we've got a plane flying, so we should deal with that one first. Let's figure out the vector to go along with the plane. Okay, constant, oops, I suppose I should make myself be bigger again. There we go. So the plane it's flying due west. So it's headed due west, straight out there. So that would be, if we needed it, that would be a trig angle of 180 degrees. So this vector, it is flying at 500 miles an hour. So it would be 500 cosine of 180 degrees, 500 sine of 180 degrees, or simply just negative 500, comma 0. Okay. Then we've got some wind action. The jet stream is in the southeasterly direction. So north, south, west, and east. In the southeasterly direction would be like that. Okay? It didn't say it was from the southeast. It simply said that it was in the southeasterly direction. Okay? Just know we are probably, because the tech questions are more along the lines of always wind being from, just know that you have to read the question to decide if it's a from case or if it's a flowing to case. Okay? So it is going in that direction. So that direction is down this way. So that would be, we're going to assume that this is a 45-degree angle. So that's going to put my trig angle at 315 degrees. It's at 100 miles an hour. So that's 100 cosine of 315, 100 sine of 315, or 70.711, negative 70.711. Okay. Again, this is true equals aim plus wind. So we aimed the plane at this one. Our wind took effect of it, so we're going to add those two together. If I add these two together, that gives me vector G is negative 429.289, comma, negative 70 points. Oh, that's a bad one, or bad vector. Looks like too much like a 7. Okay. Magnitude is going to be my true ground speed. Square the x. Square the y. And take the square root of it. That gives me a speed of 435. Oops, I put 0.074 miles per hour. I can get that. Hold that up there so you guys can see that. Okay. Gotta be innovative. My reference angle is going to be the inverse tangent of 70.711 over 429.289. That gives me an angle of 9.354 degrees. Now, because this vector is negative, negative, that puts me out here. So this would be my reference angle right there. So my bearing angle would be, this is 0, 90, 180, 270. So that's my bearing angle all the way around there. So that's going to be 270 minus my reference angle, or 260.646 degrees. So you can see that. Okay.